Same, all the programs based on this one. So these things we already discussed in arithmetic operators. Just when you divide any number with a 10, it will remove the last digit. So when you perform mod operation with a 10, it gives the last digit. It gives last digit. Just n by 10, n mod 10. Today, all programs based on this one only. Remember. Look at the next program. The program is just count digits in the given number. Count how many digits are there in the given number. For that, we need to write the code. See here, suppose same if I'm taking that n value 3652. Same I'm taking. Here it is. I'm taking one variable count because the question is what? Count how many digits are there. How can you count means what? How can you count means what? Remove the last digit. Sir, which operation will remove the last digit? N by 10. So make n by 10 and store into that n again. It will remove last digit. So n by 10, it will remove the last digit, make the n value is a 365. One digit removed, na? So increase the count value by 1. Increase the count value by 1. Again remove the last digit. So value become 36. Again increase the count value by 1. So again remove the last digit. Value become 3. Increase the count value by 1. Again remove the last digit. Final value becomes 0. So increase that value. So you need to repeat the loop until I value becomes 0. Repeat the loop. Repeat loop until that n value becomes 0. So total count if you see 4. 4. Here we are using while loop. Sir, why we are using while loop? Because we don't know how many times we need to repeat the loop. Okay. Sir, why we don't know we are repeating the loop number of times means what? Simple. That n contains how many digits you can't decide. Here, okay, I have taken 4. But if I give question mark and I ask you to write the code, I will not tell the number. Got it? So then we need to write just count equal to 0. While loop we are using. Sir, how long we need to repeat? Until n not equals to 0. When it will become 0, we should terminate. Simply n is equal to n by 10 and increase the count value. Increase the count value. Simply after that loop digits count. Digits count. Count we are printing. If you see the output of this code, if I give only 23, output is a 2. If I'm giving here it is a 365, output is a 3. Is a 3652. So output is a 4. So repeatedly is executing. Sir, how long? If 4 digits are there, 4 times it will repeat. Every time remove the digit, increase the count. Remove the digit and increase the count like this. Okay, please do. Now, see here. Next, the question is, Find the sum of digits in the given number. Sum of digits in the given number. So first one, here it is. Here it is. If they have given same n value is a 3, 6, 5, 2 given, consider. First you have to take that digit into one variable. Last digit you just collect and put it in a variable called d. Is the first step. Second step is what? Add to that sum. Take one variable sum, add that d value. Sum value initially 0. 0. To that 0, you will add that last digit is a 2. Getting the digit, and the digit you are adding to this sum. Okay. So working with the digit is over, then remove that digit. It's a third step, remove the digit. Now again repeat the loop. Loop will not change. Now d will come. D value is a 5. Add to this sum. Already sum value 0 plus 2, 2 is a 2 plus 5 is a 7. Then remove the digit. Again repeat the loop. Now d value is a 6. That 6 we are adding to that sum. Already 2 plus 5, 7. 7 plus 6, 13. Remove that digit. And finally, that last one we need to collect. D value is a 3. The 3 adding to that sum. Total 13 plus 3 is a 16. Remove that digit until n value becomes 0. Until n value becomes 0. So, how many times that loop you need to repeat means what? Condition never change, is always the same. Only just to take that variable sum equal to 0. Sum equal to 0 we are taking. First step is getting the last digit and store into variable d. D means like digit. Is what? Get last digit. Then add that last digit to the sum. Sum is equal to sum plus d. Add to sum. Working with the digit is completed, then remove the last digit. N is equal to n by 10. Remove last digit. Finally, just a sum of digits. Sum of digits, we are printing that sum. Remember this. One point, in all the programs what we are going to discuss today, condition will not change, is always the same. Getting the last digit is always the same. Remove that last digit is always the same, will be there. Only here only that logic will change. Counting, sum, printing is any operation you do, only in this line only that code will change. Logic. So 3652, that value is a 16. When you run the code, output is a 16 will come. Okay, please do. Now, suppose I just want to display only even digits in the given number. I want to display. I want to display only even digits in the given number. Even digits, not sum. Just print only even digits in the given number. So here we are not counting and we are not doing the sum. Just only getting the last digit, condition will not change. Getting that last digit will not change. Removing that last digit also will not change. I already told you, condition, getting the last digit, removing the last digit are same. Now here, if I print directly that digit, all the digits will print. But question is, print that digit only if the digit is divisible by 2. If it is even digit, then only print. Percentage D is even digit. Just a message. Now observe this. First 2 will come because it is coming from the back. No? 2. D value 2. Yes, 2 is divisible by 2. Then output will be 2 is even digit and 6 is even digit. This is the simple way of counting the last digits and sum of the last digits. Count, not last digit. Count even digits and sum of even digits. So 2 variables we are taking. Count variable as well as a sum variable also. When you find out that even digit, first count it. Count plus plus and add to that sum. Sum is equal to sum plus that digit. You know that count and sum where we need to print outside of the loop, na? Not inside of the loop. Count of even digits. Count of even digits. And next, sum of even digits. Sum of even digits is a sum. So both. Total 2 even digits are there and their sum 2 plus 6 is a 8. 2 plus 6 is a 8. Please do. Right. See, the next one is finding the largest digit in the given number. It's the same one I'm taking. N is equal to 3, 6 again, 5 and 2. See, whenever you are finding the largest digit, consider largest digit is a 0 first. Then same story, getting that digit into a variable. Into variable. Suppose D value is a 2. After getting the last digit, compare that digit with the large. Okay. If this last digit is greater than this large element, then store that digit into large. Now large is not a 0, it's 2 because we found another largest digit. So same story repeat. Next 5 will come. Compare that 5 is greater than large. Yes, 5 is greater than 2. So now 5 become the large. Next 6. Next 6. Compare that 6 is greater than 5. Yes. Then store that into that one. 6. Next 3. Just compare. No. So large contains that largest digit in the given variable. Here it is. Here it is. Now. Here it is. Finding display largest digit. Display largest digit. Taking one variable large equal to 0. Repeating the loop is the same. Getting that last digit is the same. If that last digit, more clearly, I'm collecting into last. Last means last digit. If that last digit is greater than large digit, then store that last digit into large digit. Into large, store that last. And please don't forget to write this one. In confusion, after writing the complete logic, everyone will fail in writing this one. If you don't write this one, what will happen? Infinite times it will repeat because you are not removing the digit. Na? So keep on executing with this same number only. That's why. So whatever the logic later, first condition, getting the last digit and removing that last digit is a common story for every program. Don't forget this. Okay. Now is just largest digit. Largest digit in the given number we are taking large. So when you run, that output is a 6. Largest digit is a 6. Okay, do this. Same, find the smallest digit in the same way. But see, whenever you are finding the smallest digit, here it is, don't take that small value is a 0 because 0 is itself is the smallest digit. Take that 9 because 9 is the largest digit now. Take that 9. Okay. Now same story, getting the digit, last digit. Now if you find out, see 2 is lesser than this 9. When that last digit, what you are collecting is less than that smallest digit you already consider, then store that last digit into small and then printing. Smallest digit is a small. When you run the code, that smallest digit is a 2. Smallest digit is 2. Do this. Smallest digit is a 2. This is the way. See, that code is just displaying that reverse number program. See, same, you are just finding that sum only. How you will find that sum of digits? Sum of digits after getting that last digit. That last digit you are adding to the sum and displaying that sum of digits, right? Sum of digits, printing that sum value. But a small change is what? Reverse number means only you need to add is sum into 10. Finish. Only this operation is extra. But instead of using the word sum, use the word sum. Here it is what giving that word is a reverse, suppose. Because anyway you are finding that reverse number, na? That's why. So we are just printing that reverse number is this REV printing. How this code gets executed? 3652 become 2563. First I'll show you that output 2563. Then how this code gets executed? It's very simple. First, what is that reverse value is a 0. And what we are doing, reverse equal to reverse into 10 plus last digit. First, what is the reverse value starting with 0? 0 into 10 plus what is the last digit in 3652 is 2. 0 into 10 is a 0 plus 2 is a 2. So here it is the final value also 2 I am giving. In the next iteration, you will remove this 2. Na? So next digit is a 5 will come. 5. Here I'm just writing that 3652. 2 removed. Next. Reverse value already 2. 2 into 10. 2 into 10. Plus last digit in 365 is a 5. 2 into 10 is a 20. Plus 5 is a 25. So then remove that last digit. This will remove the last digit, everyone. In the next iteration is what? Reverse value is a 25 into 10 plus last digit is a 6. 25 into 10, 250 plus 6 is a 256. Then remove the last digit. Next, value is a 256 is into multiplied with a 10 plus last remaining digit is a 3. 256 into 10 is a 2560 plus 3 means what? 2563. Then finally the 10 value becomes 0. So same, until that value becomes 0, you need to repeat the loop. Okay, please do. ఇష్టం తీసుకెళ్తే నేను తీసుకుంటాను. చూడు కొట్టించు. Okay. Now, now the question is palindrome number. So first of all, what is a palindrome number? If you take one number, let us take n value is a 2332. If you find out that reverse number, we'll give that same number 2332. It is called palindrome number. Reverse number is equals to the given number is called palindrome number. So, see, look at this. I'm taking that value is the same value 2332. And you are finding the reverse number. See, if you run that, reverse number is also 2332 came okay. But outside, I'm not printing the reverse number. I'm just checking whether it is a palindrome number or not. If the given number equal to reverse number, then we can say that it's a palindrome number. It's a palindrome number. Else, it's not palindrome number. It's not a palindrome number. But if you see the output is, whenever you are running this code, output is a not palindrome number. Sir, it's a palindrome number. So only problem here, when while loop is executing, every time you are removing the last digit of n value, finally n value becomes 0. N value becomes 0. So you are comparing the reverse number with 0. So never equal. That's why you need to take one extra variable. Let us take temporary variable. Keep the n value into 10. So what is that n value? 2332. Now temp value is also what? Temp value is also 2332. Temp value also 2332. Now you can modify the n value, no problem. Finally, n value becomes 0, but we never use n. We use a temp that you already said. Now, if you see the output, palindrome number. Palindrome number. So in this one, if you observe that details, first they have given n value is a 2332. So that you keep in a temp variable 2332. Then according to these operations, you keep on modifying that value. You're removing that n value becomes 0. Final n value is a 0. But here it is reverse value is a 2332. Okay. Note this palindrome number. Now I'll give you one task so that you need to complete. Okay. Here it is. So I'm taking that n value. N value is a 145 I'm taking. Getting that last digit. 5. Finding the factorial. Finding that factorial is a 5 factorial. So what is the value? Is 120. After finding the factorial, add that value to the sum. Sum value 0, add that 120. Next, remove this digit. Is the same story. Get that last digit 4. Finding that 4 factorial. What is that 4 factorial? Is 24. Add to this sum. Is a 120 plus 24 is 144. After that, remove the digit. Get that digit, last digit 1. Finding that 1 factorial is a 1. Add that value to the sum. So total 144 plus 1 is, again, you will get that value is a 145. 145. So the question is, if the given number and result both are same, then it is called strong number. It is called strong number. Simply to say, sum of factorials of individual digits in a given number in a given number equals to same number. Equals to same number is called strong number. Is called what? Strong number. Each digit, you know how to get each digit. And after that, just find the factorial. You know how to find the factorial. After finding the factorial, add to that sum. Please do, everyone. Start coding. First one is, I'm just explaining. So what is a strong number? Suppose if you take n value is 145, factorials of individual digits sum will give the same value is a 145. That is strong. So you are finding the sum. Take that variable sum. N value, same value I am taking. Temp is the same. Now the question is, what is the first step? Easy step, getting the last digit. Getting that last digit. Store into that last. Next one, finding the factorial for that digit. I already told you that everything is the same. Only this part will change. Sir, how to find the factorial? Take one variable, fact is equals to 1. Repeat the loop. Further, take the variable I. There only you can declare the variable. No need to do outside. For I equals to 1 or 2, anything you can write. I less than or equal to not n. Very, very important. Because you are not finding the factorial of 145. You are just finding the factorial of this last digit 5. So, last digit I plus plus. So you are finding that factorial value, fact into I. Okay. After finding the factorial for that digit, add to that sum. Sum is equal to sum plus that fact value. So this is finding the factorial for that digit. I already told you, condition will not change. Getting the last digit will not change. Remove the last digit will not change. Only in between code will change. So finally, we are checking if both are equal, then it is called a strong number. Else not a strong number. Not a strong number. If you run the code, 145 is a strong number. Okay, do this. Write the code, everyone.